Bigger block sizes often require more powerful and expensive hardware to process, which can make it hard for individuals with less powerful hardware to participate in the system. On the other hand, smaller block sizes can limit how scalable and fast the system is. Many blockchain networks choose the block size to balance decentralization and scalability. This, however, can have several drawbacks, such as those brought in during and as a result of multiple heated Bitcoin debates about block sizes. The subject of this video, Proof of Justice's dynamic block sizes, can overcome these block size problems. Now let's dive into how it works by understanding how the Speedster role works. The Speedster role is responsible for keeping the block size within certain limits, depending on the network's activity and the hardware of the nodes. This role allows a given entity to create and push a poll that alters one or more block size thresholds, as well as push votes in polls started by other speedsters, based on multiple criteria. Alongside the baseline criteria, one additional criteria appropriate for this role could be that the speedster must have been mostly constantly online and reactive for a determined timeframe and have fairly quick node hardware. Another one could be to have an average global score above a determined threshold and to never have been blacklisted. Moreover, alongside the baseline restrictions, some appropriate restrictions for the speedster role could include the number of polls the speedster can start over a determined period of time, according to its speedster level, the number of polls started by the speedster and voted in by the speedster over time, and the like. A block size threshold determines how many transactions a block can hold. This number can be different depending on the proof of justice implementation. Blocks can have multiple thresholds. Most implementations have dynamic thresholds. The calculation of a new value for a threshold can be done in various ways. One way is to look at how many new transactions there are over a period of time in, for example, the speedster's mempool. In some implementations, the requesters and partners levels of each transaction have an impact on the calculation. Moreover, transactions from untrustworthy entities may not be counted in the calculation. When the dynamic block size system is used, the size of a block would be calculated using the sum, and in some implementations, a combination of partner Petersons of transactions within the block. A given transaction can have more or less weight on the sum based on its type. A threshold would generally have an absolute maximum or a minimum value that can be set, speedsters being free to update the threshold within a specific range, as we will touch on later in this video. In some implementations, the more transactions there are in a block, the higher the default block rewards will be, up to a maximum. For example, if a block exactly meets the maximum transactions threshold, the rewards would be 100%. While if it omits a few transactions, the reward percentage would go down too. Thresholds can either be defined as hard or soft. While hard thresholds cannot be exceeded, soft thresholds allow a generator to exceed the threshold if it meets certain conditions. For example, the value of its generator level could have to be above a determined value. In some implementations, drawbacks are also imposed when exceeding the soft threshold limit. For example, if a generator chooses to go over the limit, it could get lower default block rewards for doing so, without impacting the transaction fees rewards. If a generator wants more freedom to create bigger blocks, that generator could be asked to complete a challenge beforehand or to put some assets as collateral. Thresholds can either be used to determine the maximum or the minimum number of transactions within a block. There can be more than one maximum threshold, and the same goes for minimum thresholds. For example, a soft and a higher hard maximum threshold could be used. While the goal of a maximum threshold is to avoid centralization towards entities with stronger computer hardware, a minimum threshold is made to prevent generators from sending blocks with few or no transactions in them, which could be an attempt to attack the system. Threshold values can be updated dynamically by the speedsters using a polling system. In order to generate a valid poll, the speedster needs to gather some pre-poll information. This pre-poll information generally includes things like the new threshold values, the Peterson of the speedster, and an indication of the overall distribution of nodes' hardware in the network. Once the pre-poll information has been gathered, the Speedster creates a poll transaction with it. This transaction also requires one or more partner Petersons to be associated with it, using the partner selection process described in a previous video. Finally, the Speedster broadcasts the transaction to the network. In some implementations, if two or more Speedsters try to create a poll in a small period of time, then one of the two polls will be discarded. As such, only one Speedster poll at a time could be within a given block. Several methods can be used to determine which Speedster poll will be discarded, such as the Speedster level and the frequency of poll creation per Speedster. Upon validating the poll creation transaction, other Speedsters in the network will vote whether or not they are in favor of altering the one or more threshold values by analyzing the pre-poll information specified in the poll creation transaction. A long-term memory rule can be used to analyze if a given Speedster is consistently declining polls from other reliable Speedsters and negatively impact one or more of its scores if so. Once enough votes have been cast, the threshold values will then be altered if the poll is accepted, or the Speedster who created the poll will be penalized if refused. A poll can also terminate before enough votes have been cast if a determined number of blocks have been generated since the poll's creation. The penalizing of the Speedster can vary greatly. For example, it could be proportional to its Speedster level. Moreover, some implementations will also choose to penalize Speedsters who voted against the final result of the poll. A system like the entity reporting system mentioned in a previous video can also be used to allow entities to report malicious polls even after being finalized, and have the system take corrective actions accordingly. For example, if a poll result is positive but it is later shown and proved that the poll was malicious, the entities who voted in favor of the poll could suffer punishments, while non-malicious entities who have been punished in the past could be compensated. BB Inventions, high-tech research for curious minds.